is recording. Let's take a look at this equation. It's a log equation. We know that because we see that it says log in the equation. This time it's slightly different than last time. We're going to have to use our properties of logarithms. We have three terms here. One of the terms, 1, is not a logarithm, so we can't get this to where a log equals a log, and we really can't change this form from log form to exponential form as it is. But we do have properties of logarithms that allow us to rewrite this subtraction that's on the left-hand side by the quotient rule. If you have, you can see log base of x minus log base of y, that you can rewrite it as log base of b of this fraction x over y. So I don't know if I said that right. I was just trying to read off that quotient rule, and I don't think I did a very good job doing that. Here on the left-hand side, we'll just rewrite this as a log of a fraction. This is a common log. The base 10 is implied. It's not written, but it is implied. So we have the log of this fraction, 5 over 4x minus 7. So now we've gone as far as we can go, and it's similar to the previous problem that we want to convert this log form to exponential form. So this log is base 10, and 10 raised to the first power, this logarithm equals an exponent. 10 raised to the first power is equal to this fraction, 5 over 4x minus 7. Some of you may see this, if we write this 10 as 10 over 1, as solving a proportion. A proportion is an equation. It's a claim that two ratios are equal to each other, and one technique to solve proportions is to cross multiply. So if we cross multiply, we have 10 times this binomial along one diagonal and 5 times 1 along the other. So now on the left-hand side we have two factors, and we want to get the factor that contains x by itself. We divide both sides of this equation by 10. Now on the left we have a binomial. Our first term there contains our variable. We're going to add 7 to each side. When I add 7 to each side, I'm going to rewrite 7 as 14 divided by 2. That helps me to add these two terms together because now it has a common denominator. So 4x is equal to half of 15, and we divide both sides by 4, or dividing by 4 is the same thing as multiplying both sides of this equation by 1/4. So if we multiply by 1/4, it'll help some people to see that when you multiply fractions, you have 1 times 15 and 4 times 2, and that's our answer, that x is equal to 15 divided by 8. So hey, I hope that helps, and I'll talk to you later. Oh, well, let's do this last problem. Sorry, let's do this final problem. Again, it's another logarithmic equation, but we needed to get it to log equal to a log. So on the left-hand side, we have two terms, and by the product rule, we can write the sum of two logs as a single logarithm. So all we have to do is write it as a single logarithm of 8 times this binomial. And now, because we have a log equal to a log, and because these logs are one-to-one functions, we can set these arguments equal to each other. So we have 8 times this binomial. Within that binomial, our variable x is eventually what we're trying to get by itself. So I'm going to divide both sides by 8. And then on the left-hand side, I'll have my binomial, 6 minus 3x squared. 48 divided by 8 is 6. If I subtract 6 from each side, I'll get that negative 3x squared is equal to 0. Well, it should be pretty obvious now that negative 3 times 0 is 0. But if it's not, divide both sides by negative 3, take the square root of both sides, and the square root of 0 is 0. So that's our last problem on the quiz. Hey, I hope that helps, and I'll talk to you later.